Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Winterlink. Today we're going to be looking at how to do the L in ETL, which is load, and we're going to be taking data out of one data system, a data lake, and moving it into another SQL server. Hi guys, today we're going to be continuing in our series on Azure Data Factory. Today we're going to be basically looking at how you can use Data Factory for the L in ETL, which is loads, where we can move data out of the Data Factory into something else. And that's basically just going to be making it available to external systems to consume. In the case that we're going to be doing today, we're going to be looking at how to do this with SQL Server, but it's not limited to that. So let's go look at some review, and then we'll go over to the Azure portal and look at what I did to move the data out of Data Factory into something else. So last time we looked at Data Factory, we looked at how to do some transforms and how to build a star schema. So we basically ended up with something where we had data coming into some kind of landing zone, and we were doing some kind of extraction as part of that. Now, when we did our star schema last week, we also extracted data from other online sources through HTTP. So that data was landed somewhere else, but we were just basically picking that up and incorporating it into our star schema. So that extract process is basically just the collation of data, the data collection, if you will, from different data sources into a common data repository, which in this case is a data lake. And then we did some transforms on that. The data lake in that untransformed state is what we consider to be a bronze tier data. Then we do some transforms on that, and then it becomes what we call a silver tier. And then what that basically represents is data that I can then use for some kind of purpose. Now that could be further transforms. It could be just taking it as is and loading it, which is going to be the case today. But that process that's kind of downstream of the transforms in that silver tier is generally going to be what we consider to be an L in the ETL process. So we basically take the data, move it to some kind of other state, and then maybe move that into an external data store that can either be pulled out of a data lake or use a Data Factory to actually do the movement itself. So we're not actually going to move our data more into a gold state because it's in the kind of state that I actually want it to be in the so-called silver state. So really, I don't have to put it in that state if we don't want to. We can just do the load straight into the external data store. So sometimes it is the case where your so-called silver data is the final state of what you want to look at, and that's your so-called gold data. But in any case, you end up with the data that you can take out of that silver data and put it into an external data store, which in our case is going to be SQL. And then you can take something and run a report against it, do queries, whatever it might be. In our case, I'm just going to take Azure SQL and database and then connect SQL Management Studio up to that and run some queries against it just to show you how you could use that for ad hoc type queries and things like that. So this is the schema of the data that I want to move into Azure SQL. Now, the firewall events table that I'm going to be working with has more fields in it than this one does, but this is representative of that. And it has 3 associated tables with it. And this is what I use to create my star schema. Now, by moving this into Azure SQL, what I'm basically enabling myself to do is run more ad hoc type queries on it. And that's not something that I can really do inside of Data Factory because it's more oriented around data flows and data transformations. But getting it into that star schema is exactly what Data Factory is good at. By putting it into something like a SQL database, now I can optimize my queries against this star schema. And those queries will be very fast because I'm not doing a lot of complex joins or aggregations against that data. If I was going to be doing that, I'd probably do some more processing inside of my transforms that I was doing, maybe even create another star schema to do some different data aggregations to represent that and then just present that data inside of a SQL Server database. In any case, running it in that SQL Server database would be something that you might want to use for something like Power BI through pass-through queries, or maybe some external API that's going to be consuming that data. Wherever it might be, there's a way to access that data on an ad hoc basis, which is something that Data Factory isn't going to give you. So that's why I need that load to move it out of the data lake into something that is usable by external data systems. But in any case, let's go over to the Azure portal and look at what I did in Data Factory. Then I'll show you the Azure SQL database where I actually ran my data flows and put the data into Azure SQL for that purpose. So I'm here inside of my Azure resource group that has my resources in it. I've created 2 new resources resources. I have my SQL Server instance right here. That's the virtual server. And then this is the database associated with this. And this database is just using the serverless model, which is low cost option for hosting data on Azure. But it gives me a SQL database on demand essentially so that I can use it for this demo. And this is pretty straightforward. I really don't have much in it at this point, but it is the output from my load in my ETL process that I have defined in my data lake right here. And this is something that we've already looked at right here. This transform is the one that takes the two kinds of events from my firewall data and joins them together. It's a data transform, does a join on them, and then writes them out to a table that then I use as part of my star schema, which is the primary fact table in my star schema. And then I have a few other, I have one other data flow right here that's associated with that. And that's basically just doing a data flow to move data from the firewall rules into a dimension table and it strips out unneeded columns in this select right here. The other data that I have associated with this is just straight data copies. It's just moving stuff from online resources into my data lake. And that is basically just taking the data as is in its form and moving it into the data lake. So I don't need transforms on that. Now for my data movement here, I'm doing this right here. And this is the load portion of my data transforms. Now I could probably put this right here into a data copy if I wanted to, just have a source and a destination. I put it right here because it really doesn't matter for this particular data movement. But in any case, this will actually move the data to using a data transform. And this one is just basically doing an append. So in an append operation, you would want to just basically take the data from one source and append it to another source in something like a SQL Server database. There is no updates, there's no deletes, it's just new data, straight inserts. These other three tables, on the other hand, these are the dimension tables right here. This is the fact table. So again, for moving ledger type data that is transactional. These down here are not doing that. So these are the dimension tables, and it's possible that I can update this data. I probably wouldn't want to delete it if it's correlated back to this other table right here, but this data could potentially change maybe. And so in this case, I'm basically grabbing the data source and I am doing some stuff on this particular data source right here. So this is the projection of the data. I'm doing a alter row option right here. Now this is for basically telling the data factory to do an action on the data. And so what this particular operation does is say, alter this row on a condition. Basically for my data right here, anytime I run this, I want it to do an upsert. Now I have insert, updates, deletes, and upserts. So I can do new data, I can update old data, I can delete the data, or I can update or insert the data. And I wanted to do an upsert in every case. So I'm basically just saying upsert where 1 equals 1, and that's always an upsert. You have to have this particular action inside of your data flow in order for this to work over here in the event that you're not just doing a straight append. So in this case, I want it to actually update or insert data if it's new. And that basically means overwrite existing data in these dimension tables. And so I need to have that alter row for those dimension tables to work. And then once it's over here, to make that work, I need to have an output. And that the output in this case is a table. And as part of the mapping here, the settings here, you have to create a key column. In this case, I have a key column, and that's generally going to be the foreign key back into the fact table right here. So each one of these has a foreign key basically set as the key column for that given table. And so in this case, the firewall rule ID, this is the port number, and then this is the country code. And those are all primary keys in these, but if they would be foreign keys in this particular table, that can be referenced back to these right here. And so that basically creates my star schema. So if I run this, it can move data pretty quickly. In fact, because the data is already optimized for movement, it's basically just doing copies or upserts, in that case, data copies from Data Factory into the other one, or updating data. So it's very fast. It moves data rather quickly. I think when I ran this, I tested it against a couple 100,000 records, and it did it in a matter of a minute or so, just new data or updated data into the database. So very fast update scheme there, because this is not data that is highly normalized, so it's optimized for these kinds of processes. So with that in mind, let's go look at the data results when I actually run this. So I have pulled up right here my SQL Server instance. Now this is the output, and I've just basically just connected a bunch of data to this particular SQL Server Management Studio instance using a query. And this is a very basic query. So it shows you that I have the join between the firewall rules and the actual firewall events right here. And so this might be something that I could run. And this query, if I ran this, it gives me the top 1,000 records in a matter of a second, which is very fast because the data is already transformed. And truthfully, I could probably optimize this query more by going in and tweaking these tables some, but I mean, just demo purposes here, it works really pretty well. And that's the purpose of having a star schema, so that you can actually run these queries and run them quickly against a large data set, with potentially millions of records inside of your fact table, with fewer records inside of your dimension tables that are kind of off of that fact table. In any case, this is just doing a simple join on those IDs, which in this case doesn't really give me back a lot of data traversals across multiple tables. So it's a fairly simple join, which is what you want with a star schema. So again, very straightforward and very efficient way for transactionally oriented data, ETL processes that you might expect from these kinds of workloads. So very easy to manage and very easy to set up in Data Factory.
If you like this content, please consider visiting us online at www.wintelect.com, and there you can find about services that Wintelect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintelect on Twitter at WintelectNow or at Wintelect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintelect.com. Until next time, thank you.